Hello, Zach and Hunter. This is our review problem from last Friday, and we had a cheesecake pie, a pumpkin cheesecake, and it weighed 2 pounds, and it was on a platform, and it was on the table, and I was able to pull it, and I had a little gauge to tell me what the force I was using. I pulled it along the table, and it took 1.8 newtons of force to pull the pie across the table. And the pie weighed 2 pounds. And a question was, what is, find m sub k, mu sub k, which is the it's the coefficient of kinetic friction. So we were reviewing that sort of thing. We started with the sum of the forces is ma. There are two forces, net forces. The force up and the force down canceled each other, but there were two other forces, force of friction in the negative direction, force of the pull, I was pulling it, was in the positive direction. We replaced the force of friction with its formula, and it had force normal in the formula, and then we replaced force normal with mg, which is true of flat surface. So we ended up with this, and right now we're plugging in numbers to answer this question. So, all right, tell me what numbers go in where. So, Alex, what is the force of the pull? There's a number in this picture. Can you grab it for me?
The force of the pull is 1.8 newtons.
Right, it is. All right, and mu sub k is what we're looking for. Find mu sub k. Emily, number 3, you start, I'll put mu sub k here. Start going here. What's mg? Or m or g? Either of those. I see you're stopping probably because you can't really find mass real easily, but you can find mg, because remember mg is just the weight of the object, so what would that be?
Just 2 pounds.
2. So you can go ahead and take 2 and switch it back to kilograms by F equals ma again, or F equals mg, but since we already know the 2 together, let's just replace that with the 2. mg can be 2 pounds. It comes from right there. So this is 2 in this case. Mass times acceleration. Here I would need to know mass, but I can see what's coming up on acceleration, so I'm not going to take the time to change 2 pounds back to kilograms, because, Brian, what do I foresee? What's the acceleration of this pie?
It's non-acceleration.
Pardon?
There's no acceleration.
Right, there is none. Right, so we don't need to know what the mass is. It's going to zero out anyway because of the constant velocity. All right, go ahead now and solve that equation for mu sub k and tell me what you get. Move the 1.8 over and divide by 2. Brandon, you can help us. I know I haven't called on you because you haven't seen these. So now I can call on you. What you get when you divide it? We're going to move the 1.8 over and divide by 2.
Oh, favorite equation, divide by 2.
1.8 divided by 2, basically.
0.9.
0.9, anyone confirm? What's the second? Is that it?
It's 0.9.
Alright, I'll put 0.90 for 2 sig figs. What's the unit, Emily, number 1, for mu sub k?
That's what I was just trying to figure out. Is it newtons?
No.
Actually, wait, there's none.
Right, very good. No units. No units. We showed last week why that is. Alright. these kind of problems follow this pattern. You always start with some of the forces is MA, find the force to the left and the right, put in the numbers, and find the thing you're asked for. With everything else you will know. Let's try one on our lonesome. Draw somebody pushing a trash bag that's 15 kilometers, 15 kilograms. And he could go 15 kilometers, but we're not sure. 15 kilograms is the mass of the trash bag. Mu sub S is known, so is mu sub K. Find the force this time to accelerate 2.1 meters per second squared. This is the exact same kind of problem, so I'll leave that up there, the orange work, because you'll follow the same thing. The only thing is, at the end of the story, we're going to look for something different. We're not going to look for mu sub K, because they told us mu sub K. So draw the little guy, put the forces on the guy. I want to see the forces that are acting on the trash. So do a force diagram on your drawing. Put down what is known and the question. And go ahead.
What would be the next problem? Going with the. What would be the one with the guy? Yeah.
Draw it and start with a force diagram, like these orange arrows. And start with the sum of the forces is MA, and go from there.
Ooh.
Miss Powell, when it's asking the question, is it from rest or?
I was a bit confused because in all these problems, you're eventually going to be moving.
I think from the question, from the force to accelerate 2.1, so we're assuming that it's moving because it's
So that's
accelerating.
what I would do too.
Yeah.
I just want to make sure.
Wait,
Okay.
or is it the mass? So we have mass and we're trying to find force to accelerate. If we have mass and acceleration, then find the weight.
Yeah, we could find a weight. Weight would be
And so
15 times 9.
I'll start some of the steps on the board, and then I'll stop.
So the weight would be.
I'm going to draw in the
47?
forces. Weight,
So sigma
force
sigma
normal.
force is mass and acceleration.
Those are
mass
going to cancel one
acceleration.
another,
Sigma
so
force
I'm not
is the
going to
force
include
of push
them
minus the force of
in
friction.
my equation
Force of
because I
friction
want the net forces.
Is mu
Alright, so
times
I have the
force
force
normal.
of the pull, or push this time, whichever,
I don't know.
and force of friction.
Force normal is the negative of the weight.
So there's the four forces,
So
just like we saw, it's always
so we have
good.
Mom's drawing on here, so here. So we have
Start with
sum of the
the
forces is mass times
equals
acceleration.
MA.
Yeah, I got that part.
Then we
Then
got
what are the two
force of push, which I
forces?
don't
Well,
remember
these
yet.
cancel each other,
Minus
so I must look at
friction.
force of the pull,
and
that's
Friction
one
is equal
force,
to,
and force of friction. Notice I make the force of friction negative,
times force
because
normal
it is in a different direction than the force of the
normal
pull, or
is
the
equal
push,
to
whichever,
weight,
equals
which is mass
MA.
times acceleration.
And you take it from there.
Mass times
Mass times
gravity.
gravity. And we have, look at it, so we have
Yeah, the
that'll be
mass,
15 times like 9.8,
which is 147.
147 times.
This is
Which
the
one?
thing we're looking for,
It's
so I
static?
usually circle
You're
it,
static.
so.
So many numbers on the board.
I don't know.
Start by.
Trying to find force to accelerate to something, I think
Yeah,
would be
that's
static.
good.
wouldn't it?
What numbers do you have?
Well,
Easier
I
to
guess.
see.
Oh, true, true. Good
So,
luck, man.
Anyone get it all the way through?
Okay, so we
Push.
start
is equal to 0.34 times 147.
Anyone get it all the way?
First of all, draw it.
Almost.
Yeah.
What's 147?
So first,
Times
we need to draw
0.34.
ellipses.
Yeah, this is sort of getting
Nine,
into
Wait,
that.
we're gonna force on those two cancel each other out.
Yeah, no, I
right?
was just curious.
Because it's up and
That's
down.
equal to.
Did you do static or kinetic?
All right, let me go ahead and finish the problem.
Okay.
Miss Possible
Force of the
kinetic.
pool is what I'm looking for because it says find the force to accelerate the object. So force of friction, we know, is mk, u sub k, because it's moving,
That's
mg.
16.7. So we have force of the pool minus 16.7 is equal to.
This time, we were not given the weight, we were given the mass. Remember the little squashy guy? Kilograms is mass. Weight is force. So we were given mass. When we see kilograms, we know that it's mass. So when I get force of the pool, that's what I'm looking for. Minus u sub k, 0.11. M for mass this time. Remember how Emily number 3 had to figure out that this was 2 pounds? This is different. This time we know the mass, we don't know the weight. So we're going to put in for M, we're going to put in the mass of 15. And what's the acceleration due to gravity affecting that mass? 9.8 equals mass 15 times acceleration 2.1. So when you did that,
Wait.
what did the force come out to be? I haven't seen anyone who got it to be what I got.
Yeah, that's because I forgot the 9.8.
You forgot what?
The 9.8.
Oh, okay, you thought that was the weight,
Yeah.
the 15?
That would help,
Okay,
wouldn't it?
Oops, sorry.
I'm sorry.
But now.
Yeah. So now just multiply this out, move this over by addition, and you'll have the answer.
Forgot about that part.
MG you have. MG. So MG the mass. What's its mass? You already have. And then
we do.
figure out the constant.
really
Are you
tried,
getting
but I
48
Then it's
newtons? 48.
Gravitational constant isn't in the problem. It's just something you know. Remember 32.
2.1 is the acceleration.
Well, which one do you use?
It's from the
It's in
problem.
kilograms. Which one do you use? No, you keep that. Okay, so 0.11 is your force final. So you have this force final. If you look back on this, is equal
Does
to
that one come out for you?
the MK, which you
Yeah,
have,
there
which
you
is
go.
0.11
And that's
times the
in
force
newtons.
normal.
It is in
Force
newtons.
normal is equal to mg. It's basically you're taking this giant equation and you're like, okay, that can be reduced. Okay, that can be reduced. Okay, that can be reduced. So,
Oh, that-
F of
oh.
is equal to mg. What's the mass?
That's
You
what?
Of the object.
You can
It's-
unplug it if you
math
want.
is in
Really?
Yeah, you can plug it.
15 kilograms
Yeah,
of
that's
mass
fine with
is
me.
the object.
So then what's the gravitational constant? So then
All right, look through your papers and see if you can find one like this. Before I release you to start work on that again, I'll get you one if you don't have one. I want you to know that sometimes in these problems, we have to find acceleration, do we not? And sometimes on this worksheet, they weren't kind enough to just give us the acceleration like they did in this problem. See how they gave us the acceleration? All we had to do is plug it in. Let me show you some places you can go to find acceleration. Acceleration, we know from the past, is the change in velocity over the change in time. So what's that, velocity final minus velocity initial over time. So that's one place we can go to find acceleration. And the other place is the squall.
That's that.
mass is just 15.
And we can do have at it, and we can do very attached as well.